I thought we are still in holiday mood, right? Are we not? Okay, my name is Ken Lam. I'm from the local community engagement office. Welcome to NTU. For those who are, but how many of you are visiting NTU for the first time? So, a few of you, okay. You see, maybe you are not aware, you're actually stepping on one of the top 15 most beautiful campuses in the world. You know that? Some of you know because you've been here before. But bear with me, I need to say a bit of koyo to other those who have not been here. So in Asia, there are only two universities. Okay, Peking University in China and NTU in Singapore. So one is Beida, one is Nanyang. So these are the only two which are selected by Travel and Leisure magazine of American Express as one of the top 15 most beautiful campuses in the world. So as you can see, you know, over the last few years, NTU has transformed to a mini city. There are many nice buildings, there are many nice sceneries, eateries, and so on. And you know, we have this learning hub called the Hive, and 2 days ago, we just opened our new learning center called the Arc. So again, if you have time, please explore. You know, there are so many things to see. This is the 8th edition of our Monday Talk. We actually started in July last year. So every month, normally during the last Friday of the month, we actually invite one of our top professors to talk about their research area and its benefits. Now, why are we doing all this? You see, NTU is doing very well in both research and education. Now, in terms of complete engagement, we're going to do more. You know, NTU is ranked, by the way, ranked #1 in Asia in QS World Ranking, if you're not aware of it. So we want to engage more with our community. Imagine if we ask ourselves, you know, actually, we should be very proud about ourselves because in Singapore, there are two top universities located in Singapore, NUS and NTU. And are we Singaporeans feel proud of them? Not too sure, right? So we are located in Jurong, West Jurong area. And imagine you have a neighbor who is ranked so high in the world, and you should feel proud of it. So one of the things that we try to do is to bring the community nearer, closer to the university, so that they can actually come and take a look. So we run a lot of programs with the constituency within this area. So the advisors will bring their residents to come for a brisk walk. And we normally couple with student performances as well as mini talks for the residents. So this is the first step to get to know the university and vice versa. We also do Monday Talk. Now, many of our professors are very, very now in their own areas. Now, we want to actually showcase them to Singaporeans. They are doing a lot of fantastic research. And today, a fine example will be Prof. Chua. I'll talk about him later on. So again, we want to let you know a bit about research and also the benefits, what you can get out of all this thing. So without further ado, let me first of all introduce our speaker for this evening, Professor Chua Chee. Prof. Chua, sitting over here. He's a professor at our School of Mechanical and Aerospace Engineering, the Executive Director of Singapore Center for 3D Printing, NTU. He holds a PhD degree from NTU, a Master of Science degree and a Bachelor of Engineering degree from NUS. Now in 2013, he was awarded the Academic Career Award at the 6th International Conference in Advanced Research in Virtual and Rapid, we call it prototyping, okay, for his contributions to 3D printing. And he was also conferred the prestigious Public Administration Medal, Silver, at the 2014 National Day Awards Investiture Ceremony. And Prof. Chua is the most published and cited researcher in the world in 3D printing research. And according to Science Citation Index, Thomson Reuters. So without further ado, let's put our hands together to welcome Professor Chua Chee And he will share with us the 5 C's of 3D printing: chocolate, cells, circuit, concrete, and copper. Let's enjoy it.
Thank you. Thank you very much for coming. So honored. Even my junior college friends are here. And we go back to 41 years ago, right, Chua? Where's Eng Lam? Oh, Seng is also here. Oh dear, did you bring the whole class here? So sorry, I tell them about age already, 41 years ago. Oh, yeah, Yang Ju is here. So thanks for coming. I hope your time here will be beneficial, that you'll learn something from us about 3D printing. Now, why I've chosen 5 C's is because, you know, when we were growing up, we all want our 5 C's. Next slide. Condos, cash, what else? Credit card, cars, and country club. So I'm trying to draw the parallel. So today, some of these things we can print. But I'm still hoping to print money, not yet. The moment I can print money, I won't be standing here, for sure. Next. Is it possible to print a house? Yes, people have done it. This was done a few years ago in Suzhou by one Chinese company. In fact, I went to see the chairman in Shanghai in 2013 because we just got a funding from NRF at the time, National Research Foundation. So I was given one of my 3 programs, which is building and construction. So the chairman, Ma, gave me a quotation, US, make a guess, how much is the printer he quoted me? Chua? Hang on. How much? Huh? 6 million US. So I shook his hand and said, thank you very much. I left Shanghai. And that forced us to design and develop our own printers. Today we have 2 of our own printers. We have printed things. So next time you need a bathtub, customized bathtub, come and see me. We print one for you. So this is one of the 5 C's, condo. So what is 3D printing? We have a very broad cross-section of people here today. Some of you may not even be in engineering, may not know what even 3D printing is. So I'm going to bring it down to hopefully your level. It is basically a group of technologies. It's not one single technology. There are more than 30 different types. Printing chocolate is different from printing concrete. It's all different. That's why it takes actually more than an hour to explain all this to you. So bear in mind, there are more than 30 different types. What is common though is that you take the data from a computer. So you see on a computer, you use a software called a computer-aided design, and from there you can design a 3-dimensional model. You can use the model to model a house or even a model a handphone. All things that is tangible, you can model it 3-dimensionally. Now, before 3D printing was started in 1988, was other technology, namely machining. How does machining work? Anyone knows? You have a bottle, let's say, as your design. How do you make the bottle? You take a block of material. You bring in a cutter, and you machine a lot of chips away to get what you want. Subtractive method generates a lot of waste. Why is it not using 3D printing when you already have a 3-dimensional data? Make them a layer at a time. It is actually very intuitive to use 3D printing because you take basically that data from the computer and then you manipulate to make things a layer at a time. Think of anything around the world. Everything is 3-dimensional. Everything is made of layers, right? Even a human being. I have skulls as well. This is not scary. Actually, the scary one is when you can print the real person head, put it on the table, and when your wife comes back in the night, sees your head on the table. And there are these kind of printers nowadays. They print really lifelike. This Apple, for instance. So this morning I had a group of visitors who came. I showed them this. They thought I was really offering them breakfast. Guess what material this is? Guess. It's not plastic. Paper. The entire thing is paper, including this part. And everybody thinks this is metal. It's paper. Amazing. Fully printed, fully in color. So the idea is to take advantage of the geometry that you already have in your computer, print them a layer at a time. And from there, you can make virtually all kinds of shapes. So the complexity now has very little price to pay. Over the last 30 years, there have been many names associated with this technology. In the early years, it was called rapid prototyping. In Chinese, 快速成型. So over the years, there are more than 100 terminologies. People come up with all kinds of names. In 2009, ASTM, a national body in US, felt that we should have a standard name. So the chosen terminology was additive manufacturing, basically to describe this technology as one that adds things a layer at a time. Somehow, the media favorite is not AM. The media favorite is 3D printing. Tell you a joke. A few years ago, I got my first funding from EDB, Economic Development Board, $9.9 million, and I set up the National Additive Manufacturing Center, AM, because that's the standard terminology. I use that name NAMC because in the US, there was an institute set up by the ex-President Obama called NAMIC, National Additive Manufacturing Innovation Center. So I wanted our name sounds similar to them, NAMC. Then another year later, I got a big grant for NRF, more than $100 million. And this time around, I chose the opportunity to change the name of my center. So I fought very hard for the word Singapore. So I have Singapore, right? I got Singapore. I wanted institute, they don't let me use institute, so they said use center. Okay, I use center, Singapore Center. But then I realized I cannot use Singapore Center for AM, like my previous center named NAMC. Tonight you go back when you sleep, you'll probably catch my joke. SCAM is a scam. Hence, I have to choose 3D printing, Singapore Center for 3D Printing. So if you can't remember everything I say, remember the name of the center. Singapore Center for 3D Printing. Next slide. Now, I'm going to pay a bit more time here to explain to you. I can go on and on about all the advantages, but I just want to highlight 5 or 6 of them. Why is this technology so exciting? It's not a hype. It is seriously something considered by so many companies. My center now receives more than a company visiting us per day. This morning, I hosted 6 companies. This afternoon, I hosted another one. Then I hosted at 4:30 a person that I even have to sign an NDA to see him. This is my 4th. I actually run out of you. All right, but anyway, I'm happy to be here. Let me talk about the first thing, making parts faster and cheaper without tooling. Let me show you an example. Thank you. Some of you in engineering may know that this is an impeller. For an impeller to make this by the conventional method in machining requires a 5-axis machining center, which is highly complex, takes a long time to program, and worse still, in order to machine this, you need to have a fixture, something to hold it, because when it's machining, it's very high force. To have a fixture, you have to design, you also have to make it. Then you can machine it. When you print it, why so troublesome? You just print it, and I can print 4 at one time, that's it. I don't even need something to hold it. That is the meaning about without tooling. You don't need cutter, you don't need things to hold it. You don't need to make clamps, you don't need to make fixture. And that is the advantage of this technology. Next, freedom in design. Through handphone. Do you know why your handphone is flat? Don't know. Because of the printed circuit board inside, PCB. Printed circuit boards are made by a technology called lithography. That's source of threads from the church. Printed circuit board takes about 10 layers, takes about 4 to 5 weeks to make one. Machines cost millions of dollars, lithography, but they can only make the thing flat, which is why all your handphones are mainly flat because of PCBs, is flat. So a lot of things we see today are the shape it is, the form it is, because of the restriction in manufacturing. If you think about 40, 50 years ago, a car. Why are cars 40, 50 years ago so box-like? Why not with aerodynamics? Does that mean our ancestors do not know how to design? They don't know about drag, they don't know about aerodynamics. They know, they can't make it. So that's the problem. So today, 3D printing is being explored by many companies to do things differently from before. It's opening up a lot of opportunity, seriously. So it's going to be very disruptive, just like Uber, right? A few years ago, everybody think it's safe to be a taxi driver, right? Stable job. But now it's being disrupted. 3D printing will disrupt industries. like welding, like investment casting, and so on and so forth. Give you an example of a company that does investment casting. Instead of spending the next $1 million to upgrade the furnace, why don't I just buy a printer? In investment casting, 7 steps, so troublesome. Gotta make a pattern. Before I make a pattern, you gotta make the mold. Then after that, you still gotta go through many steps. I will not go through the details, but really, it's going to disrupt many different jobs. I'm glad you're here. So, freedom in design. Third, make parts that are very complicated. The more complicated it is, the better. A simple example, maybe just this. Wait, later yours. This is a part that can easily be produced by a printer. In machining, you virtually cannot do it unless you divide into many parts. Because why? Your cutter can never reach inside. But when I print it layer by layer, no problem. Within hours, I get it done. All the machines we have are fully automated. 5 p.m. today, you push button, go ahead and sleep. Tomorrow morning, wake up, 12 hours, you get your part done. Most parts can be printed within the day. No issue. You got very big parts, then you do over the weekend. Friday, push button, Monday, collect. And we have printed very big parts. We have printed a Merlion this high, 1.2 meter high. So we are also very big printers. Now I want to show you a complex part, right, Joel? Move. So it's being controlled by my engineer here. So this is also one of very complex parts. Individual with impeller. Almost everything is 3D printed except the motor, right? So these are things which aerospace are very interested in because it takes a long time to make things like that. Parts, printing parts on demand. For instance, a space shuttle. If you recall 2 years ago, there was a movie called Martian. Anyone watch it? No? So our friend was up there stuck, right? Cannot come back. Fortunately, he knows botany. That was his undergraduate course. So he grows potatoes, he came back. But the other option is to bring a food printer with him. Then he print on demand. So when you want to eat, then you print. Because food is a perishable. Right? Print on demand. Print on demand is a very exciting topic now. I'm going to show you another example. Click, please. So I gave a talk a few years ago about this, spare parts. Will 3D printing make obsolescence obsolete? When we launched the center a few years ago, the next day a guy called me because he saw our center mentioned in Straits Times and said, Prof. Chua, my washing machine just conked up. And then I called the manufacturer, he said, sorry, you don't carry this part anymore because this was don't know version what. So it happens. So you print one part for me. Print on demand. Right. So the next slide. A lot of companies have this. Same with Singapore Army. They carry 300,000 parts, different parts from helmets to rifles to army tank and different versions as well. You keep on storing up, you're going to take out a lot of space. So one of the very exciting things that people are looking at now, can I print on demand? If I need, then I print. Then you reduce the amount of storage space. Next. Produce customized parts, implants. The world is going towards mass production, mass customization. So medical implants are one of a kind. This is for hip, a project from a Fortune 500 company from US, signed NDA, cannot mention the name. So this is titanium, lightweight. It is customized for the patient. Medical is one big area because a lot of the things are one-off and totally designed to fit the anatomy of the patient. So this is a very, very suitable application for 3D printing. Last but not least, part count. My view is this is possibly one of the most impactful examples. Later you can come down and place your order. No, not for sale. One Russian minister came, saw this, fascinated, and he pleaded. So I gave it one of this to him. This set of gears, if I tell you it's printed, no big deal. Even top CEOs thought that it's just printed, but it's printed in one go. That is amazing. 3D printed, full assembly. This vernier caliper, every single part is printed in the printer in one go, fully assembled. That is wow. All this in single go from the printer. Metals and plastics. I'm going to pass it around, but make sure it comes back. Okay. Now, Sometimes when I speak to students, I pass parts up. When they come down, from one part become 10 parts. Oops! So please don't drop it also. I'm going to show you a video. This is from GE. Take a look.
Our work with the fuel nozzle has been really groundbreaking. If we can take a component, redesign it, even if it's non-traditional in its appearance, that potentially could allow us to save tremendous amounts of weight across multiple components on an aircraft engine.
What was once 18 parts is now one single piece, making the additive fuel nozzle up to 25% lighter than its predecessor. 19 lightweight additive nozzles will be installed in every LEAP engine we build, resulting in significant fuel savings.
In many regards, we look at this technology as replacing, in some instances, traditional technologies like castings or machining and brazing and welding. One of the exciting parts about the technology is we can combine multiple components that used to be brazed or welded together and make them into one single complex unit.
By 2020, GE Aviation will manufacture more than 100,000 additive parts for the LEAP and GE9X engines. In the next 5 years, GE will invest more than $3.5 billion in new equipment to produce advanced components, like additively manufactured blades and blisks. To meet its record production backlog, GE Aviation is developing ultra-powerful laser beams and built-in inspection processes that could increase additive manufacturing speeds up to 20 times faster than what's possible today.
The gentleman you saw in the video, I met him in November. I visited GE in Cincinnati. In fact, we did a 1-week tour of Boeing, FAA. My mom just called again. Sorry. All right. And GE is basically a leading example of where the industry is going in aerospace. They have now committed first $100 million to buy 30 printers to print 85,000 fuel nozzles for production. So in future, when they sit in an aeroplane, you will have 3D printed parts. This particular fuel nozzle has already been approved by FAA. So it is confirmed to be able to fit it into the engine, LEAP engine of the airplane. In this video, the fuel nozzle has got 18 parts. They now redesign it, print it in one single go. So when we were there, we asked him, what happened to the 18 companies that make the previous part? They say it's their problem. No more job, serious. They are very ruthless. Out there is like that. So no more, the subcontractors are gone. So it's really disruptive. But this 18 is nothing great, because when we walked into a lab, we saw another one. 800 over parts, they reduced to 20 over parts. Wow, that one is fantastic. I cannot take photo and show you because they don't allow us. But this is what's happening in some of the leading companies around the world. Aerospace. Oh dear, my mom doesn't give up. Next. Now, I started 3D printing research in 1990, 28 years. A lot of people thought that 3D printing just started 3 years ago, 4 years ago. No, it has been around for 28 years. Just that it wasn't so hot at the time. What has started really was back in 2013 when the ex-President Obama felt that it was time to regain the competitive edge of US. He commissioned a study. Out of the report, the first institute they set up was the NAMI, National Advanced Manufacturing Innovation Institute. Not long after that, Singapore followed suit. That year, our finance minister at that time, Tharman, announced in the budget. In fact, in the same year, at the National Day, PM Lee also talked about 3D printing, if you recall. Since then, many governments of the world have put in huge investments. China, Taiwan, Canada, UK. so on and so forth, including us. So it is now really part of this fourth industrial revolution. Among the many things of robotics, Internet of Things, cybersecurity, so on and so forth. Next. So what can we print? Almost all the different materials that you can see here, including even circuits. I mentioned about PCB just now, right? 10-layer circuits and flexible circuits as well. So you can have wearables. Most of what you see here, we can print in the center. Okay. Next. Let's talk about chocolate. We have a chocolate printer here, but today I didn't bring any printer. Neither did I bring any chocolate. Play the video, please.
Earlier, I got a glimpse of the future with these unbelievable 3D printed creations. Fashion, statues, medical implants. But Professor Chua has even more to show me. What could possibly be next?
Is this chocolate?
Yes, and it is printing a design now.
What is the difference between this chocolate printer and the usual chocolate making machines?
If you go by conventional ways, they usually need a mold in order to pour the chocolate in. And therefore, you have to make the mold. But in this instance, you can see that we print directly without the need of a mold.
Can you put any other ingredients in there?
Well, in this instance, you have only one syringe. But if you want to have other ingredients or what we call other inks, then you have to have multiple heads. So once you have multiple print heads, then you can control each of them individually to print whatever materials you want on top of this chocolate.
So this actually looks like a prototype printer. Are you planning to sell this chocolate printing machine?
Not yet. We still have certain challenges to improve it. If we can do multiple materials, then it will be one of the first in the world to go in cake making, for instance. Do you recognize her? Jiu San San? When she came to my center, she was a celebrity, not me. All my researchers asked for her autograph. This was a program filmed 3 years ago under this thing called Secret Singapore. Anyone watch it? Secret Singapore. So they came to our center, spent a whole day, and then only 15 minutes. But not bad, 15 minutes on national television. It's quite good. Next. Now, we are also into 3D printing of food, but let me explain to you what people are doing all around the world. Freeform design, Prima came, they think that maybe you can print the decorations for cake. I don't know, they can do it. Can we customize nutrition, amount of proteins, amount of vitamins into a design? I suppose can as well. NASA is looking at long-term space travel. You need food, you print when you need it. We are also getting into the act of 3D printing. We are developing our own printer. Next slide. This project was initiated by the chief dietitian of Khoo Teck Puat Hospital, Gladys. She came to me basically because today the stroke patients, as well as the elderly, they have problems swallowing or digesting some of this food. So the idea is if you can only eat porridge, then your quality of life drops. So what we're hoping to do here is to print pure food. So no compromise on the quality. You get your steak, potato and vegetables. And it also looks good, appealing. So if you look at it, you actually can't tell it's pure form. So looks good, tastes good. Have a look at the video.
The powder first. So this is.
So it's pure form.
Is this correct? Is this correct? I have to do it a little bit because you didn't give me a dosing spoon.
So her vision is that hopefully in 2 years' time when we are ready, we are developing our own printer because we want to keep the cost down. If you buy printers from elsewhere, usually they cut your throat. So if we can get this done, we are even thinking of production. In 2 years' time, supply to nursing homes. If they need, they can choose from a catalog and we supply the food. So this will help to address some of the issues. Yeah. Next. Cells. This is possibly among the 5 C's, one of the most greatest need. Today, people are dying because there are not enough organs. They have to wait, long queue. And even when they wait, sometimes the person dies, there's no match. The organs is rejected by the recipient. So somewhere in the 1980s, the topic of tissue engineering came about. So it was about the same time as 3D printing. Then somewhere in the 1990s, they kind of crossed, because 3D printing can actually help to print some of these constructs, build an environment where the cells are so happy they multiply. So the idea is to take the cells from the patient so there's no chance of rejection, but the environment or the thing that you want to print can be designed and printed. So today we have a printer that has got 8 print heads. I can put living cells, I can put biomaterials, growth factors to construct this three-dimensional matrix of cells and things that allow and promote the growth. And this can be then implanted into the human body. So we are doing things like cornea, cardiac, esophagus, skin. You want beautiful skin? So we're doing quite a few of this. And in bioprinting, we are ranked number 2 in the world. Later I'll show you some of these numbers. So this is a biomic here done by another group overseas. Any video here? Yep, okay.
So what does the future hold? The most remarkable research work being done by Professor Chua and his team is in the 3D printing of human tissues like cornea, heart, and esophagus tissue. If they succeed, it will be revolutionary, and the 3D printed human tissue could be used instead of animals for testing new products.
So, what are some of the uses for bioprinting?
We can use it for making drug models to test drugs and chemicals on. And this will allow us not to use other types of living models such as animals.
The research team is exploring the possibility of printing transplantable tissues and organs, but they have some major hurdles to overcome.
Right now, the main challenges are to develop vascularization. Those blood vessels are usually much smaller, and we can't really just print it out.
Printing organs, very challenging. Printing something that looks like a kidney, just look like a kidney. Like, it's not about geometrical form, it is about the function. So we have to work with our friends from CELSI, the biologists. The doctors come in because of the endpoint application, whether you print a liver or organ. The 5 organs, the major organs, are the most challenging. My estimate, probably not even in the next 15 years, it will arrive. Yeah. But the day it will arrive, I think there will be a lot of black market selling organs out there. Next. This is our printer that we have, 8 print heads, cost us $1 million. And one of the greatest impact, my own view, is that in drug discovery. Today, every 50,000 drugs tested, only one make it successfully. 50,000, only one. The process of testing the drugs to make sure it's commercially available is very tedious and long because they need to do animal and human trials. Our idea is perhaps I can use bioprinting to print the tissue, do all the necessary tests instead of doing all the tedious tests. And that could shortcut the process. And hopefully new drugs will be introduced faster into the market. Next. Oh, by the way, recently one of my PhD students, the new ink that she has developed, we have actually got the company interested to buy from us. So that's one of the things where whatever IP we generate, we hope that we can get some income back. Okay, concrete. So this is my colleague and his team. So if you need bathtub, swimming pool, some of the things you want to print, Sembcorp invested $7 million into our center. Sembcorp has a unit that looks at design and construction. They have actually architects, very different from Keppel. Keppel is Keppel Land more to do development. Sembcorp actually develops houses. So they work with us for the 6 months to see what should we print. Now remember, not everything you should use 3D printing. Don't jump into it and do things blindly. At the end of the day, it should still be cost effective. Yeah, it's faster, it's nice, and it still must meet all your requirements. If you print a house that collapses on you, we are in big trouble. Or you print something, put an aeroplane, the plane goes down. So safety, reliability, quality issues, all these are concerns. And in building and construction, we are now doing quite a fair bit of work. One of the things that you can see is because in Singapore, we rely heavily on foreign workers. The productivity in Singapore is low compared to Japan and America. And this is something we want to address through automation, robotics and 3D printing, and hence this project. So we have developed two printers, one using robot, another one gantry, and these are the parts we have printed. Video, please. All right, next. Circuits. This is the last industry, the latest industry that we've added to our center. Even though it just started about a year ago, today we have, I think, about 12 PhD students working on this. So we are printing things like sensors, antennas, RFIDs. But in electronics is a huge area. There are things still like PCBs, transistor, resistor, battery, fuel cell, a lot of things to print. Some are easier, some are harder. So we have got, right now, 2 printers, and these are some of the things we have printed. Flexible circuits, stretchable circuits, and let's show the video. So this one is antenna. Silver nanoparticle ink. If you contrast this and the earlier one, you can see the dimensions are hugely different. This one is nanoparticle, 10 to the power of -9. The concrete one layer is very thick, probably a few mm, very different. In construction, few wrong is fine. The tolerance is very big. But in some of this area, even 0.5 microns is an issue. So different kind of things you print have different requirements. And electronics is huge, 600 million by 2027. These are the kind of things that people are looking at to print. Next. That's my brother. So we are doing a lot of things in metals. I use C copper, so it's so easy to remember. But we have printed stainless steel. We have printed aluminum, titanium, inconel, cobalt chromium, quite a few things. This is one of my favorite parts. Orchid, very nice, very intricate metal. If you were to join all these parts together, it will become a rod and you use it as a hairpin. If not, you just wrap around your hand, it becomes a bracelet. Very nice design. This one I cannot give you. So, show you the video. see the laser running around? So as the laser goes across, it's actually melting the powder, and the powder will fuse together. And this is how you get one layer. Very fast. So you see all this powder form? You remove all the loose powder, that's the part that you print. Alright. So actually metal is the hottest topic in the last few years. It has advanced a lot. In the past, like 10 years ago, metal was nothing to shout about. But because it advanced so much, a lot more companies are coming into metals. In Singapore, actually, we make more plastics than metal parts. But the number of companies, number of PhD students that we have, number of projects are in metals more than polymers, interestingly. So the world over, they are using metal machines to print all this kind of stuff. Medical, nuclear, turbine blades, oil and gas, jet engine, so on and so forth. Even rockets. I visited a company in the US, they make rockets parts using AM, 3D printing. Next. What else can we make? Fashion. You can see one part here. Admittedly, today they are nice to look at, not very comfortable to wear. Okay? Because it is really plastic, not fabric. So wait, the time will come when it's comfortable to wear. Not yet there. It has been used in movies. The first, I think, was Avatar, about 5-6 years ago. The movie, I have not watched it. This guy, this is a 3D printed part. And recent movies are Iron Man 3, the helmet, and James Bond movie. They wanted to blow up the car, so instead of using a real car, which is very expensive to blow up, especially in Singapore, they 3D printed one and then blew it up. Okay? So in movies are being used. Dentistry, big area. You'll be surprised when you open your mouth, there are plastics, metal, ceramics, parts that you can print. Okay? A lot of dentists are interested in this technology. And not too long ago, just in May or in Pittsburgh, Adidas already working with a company called Carbon to print this bottom piece, elastoma. So all the guys at the booth were wearing it. So this is already into production. Sports. Next. This is a very futuristic patent put up by Boeing. It is, I don't think it's demonstrated yet, but it gives you a glimpse into the future. Today, 3D printing is still considered slow. Ironically, when it started, it was called rapid prototyping. But humans, as we are never contented. After some time, we still say it's too slow, right? So, because 3D printing builds things layer by layer, Haiman, too slow. So this one is going to do it in volume and from everywhere. Take a look at this video. future. Next. 4D printing, another very exciting area. You know 4D, on a weekend you queue up. That is gambling. Don't do it. If you want to bet on 3D printing, don't bet on 4D printing. 4D, not 4D printing. 4D printing is the combination of three-dimensional printing and what? Anyone knows? Huh? Time, that's right. The fourth dimension is time. The materials we use are shape memory polymers or shape memory alloys. This material has a special characteristic. If you subject it to certain stimulus, it transforms from shape A to shape B. So you can actually pre-program it. Then you can use heat, moisture, acidity, or one of these stimulus to transform it. Very exciting. So some years back, the journalist asked me, what's the application? I said, okay, when I lie down on my sofa, it detects my heat, it transforms to my anatomy. So, but this one is for fun. The real one, for instance, smart sun shade. Put it at the office. Very hot, it actually moves to limit the light coming into the office. Then when the sun sets, it goes back to its original shape. No need to use your hands, no need to move the blinds, no need energy, no need electricity. Government loves you. This is the next big thing. People are looking at it for now applications. I'm going to show you something, a video created by my PhD student. This orchid that we have printed was specially for DPM Teo Chee when they came to visit our center June 2 years ago. In Singapore, if you come from overseas, especially if you are a political leader, what do? They bring you to botanical garden, right? They come out a new hybrid of orchid for you. So I did the same thing. This orchid is named after DPM Teo Chee 4D printed orchid. Take a look. When we first started this work about 3-4 years ago, the earliest center that we launched was, our guest of honor was Minister Lee Yi-shen, who has now left politics. He came, we gave him a polymer, he put it in the hot water, straight away changed into letters NTU due to the heat from the water. Single, almost like two-dimensional. If you think of a piece of paper and I can design such that it forms different shape, it is like origami. This is what the flower is. You can actually sequence the way it forms even. And move here first, then move there. And all this can be done by 4D printing. So actually we use multiple materials, different materials that react differently to the stimulus of heat. So you can program one shape into another shape. If you stretch this to the limit, it's like Transformer, the movie. Okay. So this is another very exciting thing that people are doing. So we are doing the science to understand the behavior. If possible, can quantify it, and then you can look for applications. Next. Well, we are university, so we have a lot of undergrads, and one of the things we do is students love competition. So this was some years back. They took part in a competition. So they were thinking, why not I 3D print part of the car, not the entire car, the shell. So we use a very small printer, the one at the back, and that's why we have to print 150 pieces of this. So we stack it out. And guess what? My colleague became famous. He was interviewed by CNBC, CNN. I'm going to show you the video, hopefully it works, by CNN.
The final leg of our journey across Singapore takes us back to school. The students here are mostly engineers, but this is no ordinary classroom. Instead, it's a place to experiment. The general rule of thumb, the more hands-on, the better.
It's not a full-time project. It's like a project of love, really.
And a project for the future. A solar-powered electric car designed and built entirely by students. The team at Nanyang Technological University has done this before, But for their 8th concept car, the NV8, instead of ordering the parts, they printed them.
So anything white, some of these components are also 3D printed, like.
So basically, it's the cabin, if you like.
It's a process that required extreme precision with 150 pieces of custom printed plastic, but also extraordinary patience because the printer took 3 months to finish the job.
Is 3D printing a viable system, a viable way of building a car?
We wish they can print one piece, like this front piece, so you need a bigger machine.
Still, the plastic combined with a carbon fibre base means this car is extremely light, about 120 kilograms without the driver. Perfect to go up against energy-efficient rivals dreamed up by other universities across Asia.
Oh, you stop it. Don't have the next part where you drove. Oh, okay. Actually, the video went on to show the CNN guy driving the car in our sports complex. He survived. His only complaint after he drove one round is, he asked, where's the air conditioning? It's too hot. Anyway, this was one of our earlier ventures, and that time, because we only had a smaller printer, so we had to print many parts. Now we have a much bigger one. Next. Let me share a little bit about my center. So in terms of the 5 Cs, I think we have done almost all the different Cs. The Singapore Center for 3D Printing aims to be a leader in 3D printing worldwide. So not just good in Batam, Johor, and Singapore. We hope to be well known all over the world. We have a video as well? Okay, show you the video.
The Singapore Centre for 3D Printing, or SC3DP, funded by the National Research Foundation, or NRF, the Nanyang Technological University, or NTU, and industry partners, aspires to be the world's leading research institute in 3D printing to achieve prominent and outstanding breakthroughs in the research and development of innovative 3D printing technologies, processes, and materials. This will be done by attracting leading researchers to the center and nurturing a skilled talent pool, establishing strong linkages with and delivering state-of-the-art and innovative solutions to the industry. SC3DP will consolidate all of NTU's existing competencies and strengths in 3D printing for manufacturing and precision engineering industries. SC3DP, which is led by a strong team of professors renowned in the area of 3D printing and supported by more than 30 faculty members with different 3D printing expertise, has 3 key research capabilities: modeling, materials, and design. The center also houses a wide range of facilities and equipment and has received strong financial support from the government to further its research in 3D printing. In collaboration with industry partners, SC3DP will focus on key industries including aerospace and defense, building and construction, marine and offshore, and future of manufacturing. The center also actively collaborates with local and global partners, from equipment and materials manufacturers, software companies, to certification bodies. In 2013, a 5 million Singapore dollar joint lab was set up between NTU and SLM Solutions Group AG, which aims to develop the next generation of metal 3D printers.
SLM Solutions, as the technology leader, is very proud to collaborate with NTU, Nanyang Technological University. We decided together to form a joint lab to have a research and development. The common research is especially of high interest for the aerospace, for the automotive, and for the energy industry.
We at UL are delighted to partner with the Singapore Center for 3D Printing. We selected the Singapore Center for 3D Printing because of the infrastructure, resources, and the commitment from companies to advance 3D printing. First of all, there's a lot of research that's needed for us to understand the science and the safety behind the materials and the processing of 3D printing.
Besides working closely with the industry, the SC3DP also prides itself at developing spin-off companies and products. Blacksmith Genesis is a spin-off product from SC3DP, invented by the Blacksmith Group, Singapore's first all-in-one 3D scanner, printer and copier. The centre organised 3 firsts in Singapore in 2013. The first 3D Printing Festival, the first Singapore International 3D Printing Competitions, which saw a total of 30 entries from 7 countries, and the first 3D Printing Fashion Show, which featured competition submissions and fashion pieces from renowned designers. With its mission to train a pipeline of researchers and practitioners for sustainable growth, SC3DP offers a range of postgraduate programs supported by NTU School of Mechanical and Aerospace Engineering. The centre aims to train at least 100 PhD students and 27 full-time researchers in 10 years. The research work at SC3DP will bring about endless possibilities in 3D printing or even 4D printing. Cars, clothes, food, medical implants, human organs, smart structures, printing in outer space, and unimaginable applications can be researched upon and 3D printed in the near future. The Singapore Centre for 3D Printing, printing the world and beyond.
We have today in the center 49 professors where we draw faculty from all over the campus. So we have people working in construction materials, helping us with the building and construction program. We have people from biomedical working with us in bioprinting. We have the material scientists who help us with all the formulation of materials. So the idea is that while there are colleges, there are schools, there are no boundaries. Any prof can work with us in the center. We also bring in visiting professors. There are some people who will not join you full-time, but they don't mind coming for a short period of time. So this community is not that large. We almost know everybody after 28 years. So these guys will come for a couple of weeks, we pay for them, they spend some time, hopefully to inspire our researchers. So almost all the top gurus in the world, we know each other. Full-time researchers, we have 31 of them, mainly postdocs. PhD students, right now we have 103 PhD students. Concurrently, they are doing all on 3D printing. This statistic alone should make us the largest center in the world. Stefan? I am quite sure because I know who is who in the world. So this is huge number of resources. And later I'll show you a roadmap of what are these guys doing. How many are in metals, how many are in concrete, out of this 103. Now as is not for the sake of science, we don't just work on science. Our idea at the end of the day is still industry. So we spend a lot of time with industry. I entertain at least 1 company visit per day. Today I had 7 companies. Very busy. But at the end of the day, whatever nice science we do, we want it to be translated into applications and commercial products for the industry. So many of you here are from companies. Later I'll print myself a few more, then we will talk. But I hope you will not just stop at today's talk. Hope you'll come back. Next. We are very well funded. The history, I've been here for 28 years, is that only in the last few years, money has been raining down. Before that, there was time I was so poor, on my knees, no money still. Right now, it is almost a golden era for 3D printing. If you have an issue, talk to us. Don't worry about money. We'll find the money later. First, tell me your problem. Then we'll find the money later, if we can provide a solution. All right? There is money for 3D printing. Seriously, I know where the money is. We'll help you find them. Come up with a problem. If it makes sense for the company or for yourself to make money out of it, then we have a plan. All right? Whatever idea you have on 3D printing, always don't tell anybody, just tell me. But I'm still very poor, I don't know why. Anyway, We have a lot of funding from government, but also from industry. Out of the 150 million, 30 million is from industry. These are our three major partners. Very specific areas, we get them involved. Later, I'll show you some other companies from around the world as well. Next. These are all the printers that we have. Today, there's no time to show you. You did see some in the videos. But should you want to come back, let me know. Let my girls know. Let my guys know. We will arrange for you. Okay? Don't worry, I don't charge you. Come and visit. The machines are very expensive. No point buying expensive toys and they become white elephant. It is important for us to work in industry. So the government has already invested. We will use that machine to do your project. So that's our in-kind contribution. So you have a problem, come to us. I can tell you how expensive this machine is. Most of them are 7-digit. Only the chocolate printer is 7,000. Only 7,000. When 7,000 compared with 7-digit, 7,000 is very cheap, right? Very expensive machine. That machine is more than 2.5. That one is 1 million. This one is 1 million. That's 1.8 million. This is 2.5 million. They are all very expensive machines. So, sorry? Lifespan of the machine, very hard to estimate because they are all so different. But let's say the first one I bought in 1990, that's the year I started my journey in 3D printing. We used it for 8 years, the SLA. 500,000, 8 years, hundreds of projects. Worth it. Okay? So different machines, different lifespan. Now, there are also very cheap printers out there. Chinese saying, 一分钱一分货. You can buy from Taobao. $300 machine. Don't expect it to function like the $3 million machine. If you can, tell me. I also want to know. So bear in mind, you can print nice titanium, let me know. These are the real industrial grade machines. Otherwise, the companies will not come. Next. Oh, by the way, what you see are commercial printers. What you don't see are printers that we develop. That one we don't show you. And sometimes companies give us money and tell us not to do anything to the public. So it cannot be even be open public domain. I'll show you some examples. Now, I hope you don't mind we do a bit of bragging. After they can bash me up. In the world, if you look at publications in Web of Science, the de facto database, and you use the 3 keywords, in the early years it was called rapid prototyping. Later, it was formalized as additive manufacturing, but today everybody prefers the word 3D printing. Use any 3 of these keywords, search in the database, NTU is right at the top. We are more than double our friendly neighbors down the road. But I don't push them down because I got 2 degrees from there, more than here. I'm just saying as a matter of fact, okay, nothing wrong with NUS. The top 3 has not changed in trends. I monitor the trends as well. Last 3 years, always the same top 3. 4th to 10 goes up and down like stock market because they are very close to each other. So this is where we are. What about individuals? Next slide. The top 100 scientists in the world in this field. The first one is my brother up there. 3 from our centers. Number 2 and number 3. And we are very far ahead of the chasing pack. I doubt anyone can chase us, seriously, given the kind of skill, the scope that we have. Okay. Therefore, we have the next slide, which for sure you will laugh. Next. 天下第一. Number 1 in the world. I told my colleague to prepare this for a center briefing. I said, you go and find a 武侠片, you know. One that has 3 swordsmen, just put our photos there. And I am Li Lianjie, you know, Jack Lee. So we are really 天下第一. So you know about Chinese days, you know, old days, they like to take the sword, go around and challenge, right? Let's fight. 你赢你就第一啦，东方不败 or whatever 啦. Okay. Next. Now, just now I show you 103 PhD students. This number that you see here shows you the number of people involved, number of PhD students involved in the area. So we have 7 guys doing concrete, 25 guys doing metals. Huge number. Food, very small. 1 only. We just started. So it is not our specialty yet because money is not, you know. So a lot of this is driven by grants and industry. In the industry, you want to put money on the table, we will do the project. Okay. So this is where we are. 6 verticals, the industry from aerospace all the way to electronics. 5 horizontal. We call it broad-based. A PhD program is 4 years. In other words, we do the science for 4 years. After 4 years, you will become very good because every day you think, dream, eat of titanium. That's all you are. 4 years later, you should be very good. You're no good, that means I don't know what you're doing. So that's what we do. We turn all these guys into domain specialists. And this is what the industry wants. To bring big companies into Singapore, EDB knows that we need the skilled talent. Are we behind time? We are already behind time. I have 100, but they take 4 years each to train them. So this year, I've graduated 15, but companies need 20 and 30. Where to find? So we are behind time, seriously. So don't worry. A lot of people think, hey, wow, 100, can they find employment? Yes, they can find. We just track where our graduates are. My own PhD students in the US. So we also lose some of them. We have 2 guys in the US now. And then all over Asia as well. So later, anyone interested in PhD, find me. It's okay if you are 50 years old, like me. Still can do PhD. It's called permanent head damage. Come and do if you are interested. Next. Just to let you know, sometimes you don't know, hey, what do the companies want to do? Actually, bottom line, all the companies want to make money. Serious, they only want to make money. They give you money because they want to make more money. So there must be ROI. PTT, number 1, the biggest in Thailand. Anyone from Thailand? They are number 1, Fortune 500. They came to us, straight to us, because they know we are good in 3D printing. They have a lot of materials that they produce, but they are not 3D printable. If now I can make this chemical or material 3D printable, I got new market to sell. Very simple logic, right? They came to us. Within 6 months, we got contract signed. It's one of the fastest. Usually, it takes about 1 year because 6 months of candlelight, the part off first, then candlelight. Then 1 year later, walk down the aisles. That's generally about 1 year. PTT was very fast. 6 months, we got signed, one project. Working more for automotive, because in Thailand, they make a lot of cars. Bosch also work with us for automotive application, even though we don't produce cars in Singapore. PTT and Evonik, these 2 are materials companies. So the idea is to help them sell the materials that they produce. Evonik, they are looking more at additives. How you add this to improve the performance. That's one category, material. Second category is machine builders. These guys make machine, but they still want to improve the machine. You saw in the video SLM, they are doing the next generation printer with us, metal printers. So that is the second category, machine builders. We are now working on one which will help us to even increase our money value even higher. I hope it will land next month, all right? Watch for the newspaper. The third group are the end users. So ST Engineering, Aerospace, Semcorp, Buildings, Marine and Offshore is Keppel. They do oil rigs. These are all the end users. They look at application. They have products that they make, but they now want to try 3D printing so that it's faster, cheaper, or whatever reasons. So they come in. And another example will be Emerson. They are world number 1 for valves, for oil and gas, for process management. You know how big are their valves? Make a guess. 2-story high. That's the kind of valve they make. So they have conventional ways of making valves. They now want to look at 3D printing ways of making valves. They came to us, $500,000. Panasonic, very interesting. They came to us, they say, I don't want to ignore all these current processes. I want a new one. Patricia, a new one. A new method. So I said, how much you have? $1.5 million. Okay, let's go. So we have a call for proposals. The professors write the proposal. We chose 2, asked them to present. We picked the very best. Our Korean colleague got it. He worked on it. It's so secret that I don't even know where the lab is. Serious, yes. I'm telling the truth. But I also don't want to know. So they do something, I don't know what they're doing. Let them do what they do. Because a lot of these projects, the company insists on NDA. So we don't want to know what they're doing. So if they pay, we have to do it. What else? I think one of the most challenging recent projects we undertook is this, DSTA. Restoration of damaged PCBs. In the Ministry of Defense, there are a lot of weapons systems that they have used with electronics on them. And over time, wear and tear, these electronics get damaged. The idea now is to repair. This is very challenging. Repair manufacturing parts, yes. No, not so challenging. This one is repair PCBs. PCBs are very, very fine. Not easy project, but my colleague has taken up the challenge. So this is just a sampling of the kind of projects that we do in industry. So materials, machine, application. The fourth category are safety. UL, you saw the lady in the video. She used to be in the US. They were considering whether to go Shanghai or Singapore for their R&D center. EDB asked them to come and visit me. I changed the S, to this S. So she didn't go US, so now she's in Singapore. Sorry, she didn't go Shanghai, she came to Singapore. Now they have a big center. In fact, a number of these companies are now big in Singapore because of the support from EDB and working with us. Emerson, DMG Mori, SLM Solution. They used to be nothing in Singapore, now they are big centers doing R&D here. So safety is very important. UL used to be, when you do a water heater, you put a UL stamp, it says that the water heater is safe to use. That's what they want to do. They want to look at safety. One of the projects we started with them is, they say today, right now, there's no standards governing printers being used in homes, in schools. Right? Your children in school use printer, is there any guideline? Nothing, right? Then how to tai chi how? So we are looking at safety issues being used. Printers are everywhere now. Really, there's no safety standards at all. So we're working with that. For Lloyd Register, it's more in marine offshore. They are a classification body. Okay, next. We have official MSc, PhD programs. If you're interested, you can find out from us. You can sign up. Next. We have a lot of visitors, VVIPs. He came. I gave him my book. But this one old edition already. My new one is there. This is 4th edition. Now I got 5th edition. And I gave him the orchid also. Next. This story I must tell you. Luxembourg. Luxembourg Prime Minister was here 2 Novembers ago. Their team came, 3 wise men in June, told us that they want to work with us in 3D printing. They are very good with composites, the 6C that I want to print. Follow that, they asked me to go over to present to their guys. So within 1 hour, I persuaded all their guys to loosen their purse and give them money. But they got money I don't have, so I'm still not very happy. So next thing is they brought their Prime Minister, no less, to Singapore. And overseeing the signing of PM Lee and him, they signed an agreement between their funding agency and our NRF. Now I'm happy already, because now I also will have money soon. So we have now put up 4 projects. Hopefully we'll land in May this year. 3D printing of composites. And we are talking about 2 million euros that side and 2 million Sing here. So maybe about $4 or $5 million. That's my 6C, composites. Very important area. If you know what composites are. In the aeroplane, at least 50% use composites. Lightweight yet strong. Next. We have more than a company visiting us per day. Today I have 6. If you take away the weekends, it's more than 1 per day. So I need to print myself. Next. This is a conference that we organize every 2 years. The next one is in May. Next. This one, if you're interested, please take part. I started it in 2013 with the Singapore first 3D printing festival, including a fashion show. The ladies you saw just now, they're all students, not professional models. Because I'm very poor, no money to pay professional models. So ask NTU students, give them gift voucher. And they, 1 hour crash course to do catwalk, then off they go. Yeah. But lucky they didn't break all the parts, because I borrowed all those very nice pieces that has been catwalk in Paris. Very nice parts designed by famous designers, no less. So we started in 2013 because at the time in 2012, one guy came to my lab, investor, really rich. I didn't expect him to give when I asked. He gave me $60,000, serious, to start the competition. So we started it. Since then, we have been doing it every year. $40,000, because I even created the Singapore category. So these 2 are for students, tertiary and even primary school. Of course, printed by the parents. 5,000 for Singapore students. This one is worldwide, 10,000. 20,000 for one team, another 20,000 for another team. So every year I give away $40,000. And the guy who started all this in 2012 recently came back. It's just strange, he just came back. So I said, hey, I can't see, since you came 5 years ago, a lot of things have happened. He came, then I showed him what we are doing, blah, blah, blah. I said, oh, this one we got sponsored, you don't need to sponsor, everything. Then before he left, he said, I'll still want to give money. Give me $50,000. Sorry, he gave the center $50,000. I wish he would give me $50,000, but it was for center. But the good thing is that you do whatever you want with the money. That's very nice. But you appreciate the work that we have done. That's the good news. I'm not hinting that you should give me money. Next. But you want to give also can. This is a course that I've run since 1991. You all believe it? I run this course for 27 years. So when I teach this course, I can close my eyes and teach. 27 years. First year I ran, after a few years I said I should write a book. So my first book was in 1997. Last year I published the 5th edition. Every few years you have to write. And this job is very tiring. We call it in Hokkien, he chuan. Very hard to catch up with this technology. Every day there are new developments, serious. 不是讲笑的, it's real. So this course right now is supported by Skills Future. Used to run only 2 times a year, sometimes a class 10%. The last course I just ran in January, 50 people. Why? Because you got the subsidy. If you are from SME, the course fee is 1,600, subsidy is 1,400. Because you are away for 4 days, they pay you 210. At the end, you not only pay, you make $10. SMEs here, anyone? Make $10. And I said, you have 4 lunches, because it's 4-day course, 8 tea breaks, and very good food from 4 seasons. Get a souvenir, get a certificate, get a copy of my book. But I say autograph cannot, because that's $3,000. Very popular course. If you're interested, we even have registration later. Okay, so next. This is for non-SME. So as long as you're Singaporean PR, there's subsidy. But you don't make $10. This is a lesser subsidy. Next. So this is, I think, the last class we did in January, about 50 of them. So you will see all the different pictures. So there's also a workshop. It's not just theory. Next. You get a souvenir as well. Personalized. Here you can even use Chinese name if you want. The last request I had was Korean name. And even bilingual. You can either choose your name John, or your wife's name, or your pet's name. Some people do all kind of name, I don't care. They print it, they do hands-on. So we give them some hands-on. So nice, customized piece. Next. Actually, people ask me, I don't know engineering, can I come for the course? I say no equations in my course. So I had banker, artist, dentist, dietitian, all kinds of people coming to the course, no issue. I had one banker who came from Stanchart. She came in a Porsche. I wish I've done banking. Porsche. Because on the last day, I had to go to the workshop. Or third day workshop, I need to organize carpool. So I say, who got cars? Put out a hand and say, I have. He said, Prof, I have car, but only can take 1 more person. Why Porsche? I say, I'll be that one. But they want, you know why banks want to come? Singapore? Print money, yeah, good ones. Why? Because they give out loans. So they need to know, is this guy from Marine Offshore safe to give loan or not? This one, aerospace can give. So they want to know, 3D printing, which area high risk. So they come in, and not to print money. So banker comes, dentist, architect, all kinds of people. And sometimes I wonder why even in Singapore you don't come for the course. These guys flew all the way. I had one UC Berkeley professor flew all the way from US, arrived on the course morning. And I said, are you sure you can stay awake? He stayed awake throughout the whole day. Fantastic. And he was not alone. There was another guy from Norway, also flew all the way in to take the course. And they lasted the whole day. I think my joke quite good, so they stay awake. But these are all the guys who have actually spent time flying in. Serious. I had more than 20 Russians from the aerospace. They do rockets and things like that. They also are surgeons who do all the implants design. They actually flew in to take the course. Okay, next. We have published 4 books. My first book on the extreme right, or your extreme left, was my first book in 1997. This is the 5th edition. We have since published other books in bioprinting, lasers, and standards. More specialized books. Next. Our center motto is printing the world and beyond. Beyond. Because, next, even NASA had a competition recently. Because one day Mother Earth will run out of space. We need to live on Mars. So can I use the material there to make the house? So they had a project, we participated to print things using the material there. It's the same thing for many of our concepts. In the Sahara, there are lots of sand. Can I use the sand there to print the house? Instead of, we have to import a lot of sand. So you can use the material that is there. So printing the world and beyond. Next. But there are two things we don't print in the center. One is money, of course. The second is, we'll show you the video. Money, of course, yeah. We don't print gun. We don't do weapons.
My name's Eric Muchler. I'm a project engineer here at Select Concepts, Austin, Texas. It is the location where we hold our federal firearms license. And we have just produced our first 1911 pistol via DMLS. The slide, the frame, and many of the internal components were made out of stainless steel 17.4 DMLS product. A couple of the items were made out of Inconel 625, such as the mainspring and the beaver tail and the hammer, and we did SLS on the grips.
When we decided to go ahead and make this gun, we weren't trying to figure out a cheaper, easier, better way to make a gun. That wasn't the point at all. What we were trying to do was dispel the commonly held notion that DMLS parts are not strong enough or accurate enough for real-world applications.
She's hot.
Why did he use a rope to pull?
3,
huh?
2, 1.
Get it in his face, huh?
3, 2, 1.
Well, it works, huh?
Looks like it went over the berm.
So after 2 shots, he feels safe enough.
First 1911, it's all DMLS except for the springs. So we're gonna try 3 rounds, 45 Winchester white box.
Accurate or not? Huh? You think it's accurate? Not accurate. How do you know it's
landed
not
on my
accurate?
shoulder and stayed there till my third shot.
No, I was watching the...
Accurate or not? Want to buy the gun or not? This one is forbidden. I have police advisory, no guns. So I told my researchers, don't print weapons. Don't get me into trouble. So no weapons in the center. I also told researchers don't do anything that's sensitive to racism, religion, as well as pornography. And it's happened in Japan twice. Once, 2 guys printed a gun, they ended up in jail. Then a short period of time later, a lady designer took photograph of her own private part, designed to a Mano 3D printed it, and guess where she landed up? Behind bars also. Also in Japan, I don't know why. Strange things all happen in Japan. Next, money. Money I haven't learned how to print, but if I know, I'll tell you. Next. Let me tell you what we really don't know. A lot of things we still don't know. We are barely at the surface. We are really new to 3D printing. Today, people are trying to do all kinds of things. We are only at the tip of the iceberg. There are many challenging things, including human organs. We are very far away. And every day, even though I've been involved in 28 years, I'm still surprised by people. They try to do all kinds of things. Recently, I saw one, this guy printed a stingray. So silicone to build the body, inside got red muscles. And this stingray can swim some more because they use light. And the light, because of the light, 4D printed. Red muscles, it reacts, it swims. This is not your Newton circle stingray barbecue. I know you're hungry. But 4D printing, another example. I tell you, it's amazing what people are doing out there. Every day there are new things. Okay, so this is just to give you an idea of different difficulty level. Not all things are achievable. And really, there are a lot of things we still don't know about 4D printing. It's still very new to me in 30 years. Still another 30 years to go. Next. This is my last slide. I want to share a story with you. This was told to us by our new president just in January. I thought it was a very nice story. You know we have a new president? Subra Suresh. So he joined us in January. And he used to manage the National Science Foundation. Every year is don't know how many $billion that he will give away for research. 7 billion every year. Of course, our budget compared to them is very small. So one day, something happened, a typhoon struck this place. And he called up the guy who said, hey, I've given you so many millions to do research. How come this kind of thing still happen? He said, yeah, my prediction of where the typhoon will hit is so accurate. I can predict it will hit here. The problem is I cannot predict the human behavior. These stubborn folks remain there. You tell them, go, go, go. No, I want to stay here. Then they get hit by the typhoon. So my story is this. You have heard my story, right? You heard about 3D printing, how disruptive it is, how useful it is. What is your reaction? Oh yeah, so what? It's over to you. Up to you. What do you want to do? You want to learn more? You want to visit us? You want to sign up for the course? I even have on-site signing if you are interested in the course. Like I've said, if you are SME, Singaporeans, $0, earn $10 some more. Okay? Q&A. Please ask all the things you need to ask. Wow, first one. Thank you.
My name is Sunny. I'm
Hi.
retired.
Hi,
My
Sunny.
question is, you've talked so much about all this. I'm so impressed by it, but you may have missed out on something.
Okay.
With the human feelings, with the hearts, social activism, and a conscience. Why don't you print Korean comfort women, many of them, thousands of them, and then I'll send them all over the world. You can find them in Timbuktu, in Douglas, Africa. Them in Tuvalu, the deepest and most isolated area.
Print woman.
Tuvalu. Tuvalu is a country.
No, no. You want me to print woman?
Woman. Comfort woman. In various shapes and sizes, polymer, and because this is to do with our human conscience, and which is very topical and getting more and more important every day.
Sunny,
but
right?
Japan is rejecting this. Say, we didn't do it. You proved to me. They have a lot of proof, So it's to do with our human feeling, our civilization.
Very clear. Huh? We don't do cloning. No Dolly the sheep. I gave a talk to the Marine Offshore community, 300 people, 4 years ago, Chua Annual Memorial. Again, one of the veterans in Marine Offshore. When I talk about 3D printing or living tissues, he said, Prof. Chua, are you trying to be God? No, no, I'm not. We are trying to address a specific shortage of organs. Again, we are not cloning people. We are not printing people. So for sure, no woman that we're going to print.
Just statue.
Printing statues? Well, people have printed figurines. Oh, print the statues. Not an issue. If you have money, we will print.
How much?
Expensive.
Money for you.
Titanium is expensive. I can tell you it's expensive. If we did one, this one is more of a national service. There was a class, the former provost, he did a class at a management course in Civil Service College. Every year when the class finishes, all the potential ministers will do a class photograph, a bike 2D, class photograph shot there. So he said, Chika, I already told them that we are very good in 3D printing. I want a 3D class photo. Thank you very much, a lot of work. So I have to send one guy down, 3D scan. Don't move, 15 minutes, scan, because must be realistic, right? So scan. Then go back, model, print, metal. But I have to subsidize. I cannot charge in my boss. So I subsidize the machine cost, but pay for the consumables. Still, it costs 5 digits. Very expensive. Metals are expensive. Cheaper are plastics. Paper even cheaper. You're interested in paper. It's possible. We can talk, Sunny. Okay. Any other question? Wow, so many. Yeah.
Good evening. I'm Albert Cheng. Spent many years in offshore and gas.
Offshore,
I just, I felt very interested. You talk about metal printing.
Yes.
Particularly tungstens or very
Tungsten has
exotic
been printed as
metals.
well. Yeah.
Now, in offshore industry, we are very concerned about quality.
Yes.
How do you manage the mechanical properties, the thermal properties?
Yes.
Like subsea pipelines. Many a times, if the pipelines is burst, millions of dollars and a lot of pollution. Likewise, you spoke about building oil rigs, jacking systems, which is also very important for a rig. So I'd like to know how, during the printing, how did you manage to ensure the consistency of all these properties? Because basically, we want it to be reliable, and also the quality, the contents of the.
Sorry, I didn't get your name. Your name?
Albert Cheng.
Albert.
Yeah, I used to work for Semcorp, DNV, ST, all these companies.
Keppel is our main partner for marine offshore. I fully understand what you're talking about. They are a very conservative industry, and oil rig has been there for hundreds of years. Please don't touch it, otherwise the oil rigs will. So we understand. A lot of things they want to do are very high tensile steel. So I can tell you, doesn't mean I can solve all the problems. But for sure, all the issues you raise are also their issues. Keppel will want to make sure that whatever print is reliable. The quality issue cannot be compromised. Even if tell me it's cheaper or faster, no compromise. When we did a project with DSO on copper and aluminum, same thing. If I print my rifle, faster, cheaper, but if I go in freezing Moscow winter and I pull the trigger, it doesn't work, die, our soldier. So it must function. So no compromise. In terms of functioning, all the requirements must be there. After you settle that part, then we talk about how fast, how cheap. So no compromise at all. So we do all kinds of characterization, all the tests that we need to do, whether it's fatigue tests, extreme weathers, all these are necessary. Now, in the industry, I agree with you, it's very challenging. So even the classification bodies are involved. DNV is involved with Semcorp, there's one group. Lloyd Register is involved with Keppel, same issues. So what we've done with Keppel in the last 2 years is just focusing on materials. So we are now choosing the material which will meet their requirements. And then next, then we go and do 3D printing of the various shapes, the kind of parts that they want. What is the thing you should print? What is the thing you should not bother to print? Understand? So don't go away walking out the door thinking that Prof. Chua said, let's print everything from tomorrow onwards. See liao, my reputation gone. So remember, not everything. You need to spend time, work with us. At the end of the day, no compromise on your quality. You must still meet all the stringent requirements. It must not fail. Anytime if a part fails in the aeroplane, it's a disaster. The plane goes down, a lot of people die. So no compromise on safety, yet then it's faster, cheaper. Yes, those things will come. If not, then it doesn't make sense, don't do it. All right? But it is coming on slowly but surely. And my own view is in 5 years' time, this will become mainstream. Today, a lot of people are still, okay, let's wait. But I can tell you, all the big boys are already in it. Soon, the smaller ones will have to pull along. If not, they are luck. So we're actually trying to build a whole ecosystem so that the SMEs can support the big boys. The big boys have the muscles, financial muscles to try things out. I don't know whether I have fully answered you, Alfred, but we understand the industry because we have Keppel, Semcorp, and ST with us. So we understand from where they are, requirements are very stringent, cannot be compromised. But we have demonstrated, especially with DSO, that some of the parts we print are better than the way they do it conventionally. Better strength than investment casting, for instance. Better properties. I saw, sorry, there's a boy. I'll let the boy answer. Yeah.
Hi, my name is Ryan, and
Hi,
I'm
Ryan.
a student and a technology enthusiast. I'm just wondering, when you talked about biomaterials, I immediately thought of the human brain, and I was thinking that if you could, is it possible if you could expand on the concept of 4D materials, where the materials react to stimuli from the environment, and use the biomaterials to add some sort of like artificial intelligence in how like how the human brain works? Is it possible to do that? And if it is, how many years can we expect to wait before that becomes, yeah?
Probably not in my lifetime. The human brain is very challenging. We have done some work in neural applications. but it's really challenging. I tell you, in the area of bioprinting, what is the most challenging thing is actually the blood network. The organ inside has got a lot of vessels. The challenging ones are the small arteries. It's so fine to print. So when you have organ, you need oxygen to go in. So it's not just the shape of the heart or the shape of the liver. You actually need all these blood vessels. And that is the most challenging part today. So people are trying to print spheroids, small little things that represent the cells and grow from there. Neural, there are some work done, but it has not reached the stage of commercialization. The things that people have commercialized so far in the area of tissues and organs are the easy ones, like the bones. The bone has been done. We've done it many years ago. You can print, put in the rabbits, all that can be done. But the 5 organs are the most challenging, and definitely the brain is. On your topic of artificial intelligence, we are right now working with a company, not so much to do with the brain, but using AI in 3D printing. So we're trying to combine these 2 areas. So a lot of things can be done in 3D printing using machine learning and other AI tools. So this is an area where we are trying to merge 2 very important technologies. Sorry to disappoint you. Come back to you. Don't fall down.
I see most of the investment that are being done by the end user to meet their own requirements, like GE, their own parts.
Yeah.
So when do you see the market big enough and mature enough for a third-party independent provider, just like in the contract manufacturing, produce for end customers? When would that be ready?
In a matter of years. There are already contract manufacturers coming in. In Singapore, one of the players, Mayban has come into it. They have bought a machine. So they are also monitoring the space. The big boys, after some time when they get the assurance that this is the way to go, it can really make money, they will pull in all the smaller boys. So there's a whole supply chain. We need the subcontractors, we need the SMEs, so that everybody move along and they don't fall behind. So we need to take care of the SMEs. I have not highlighted my fault, the SMEs. We have done quite a fair bit of work with SMEs as well. We have quite a lot of projects with SMEs. Maybe I'll just share one. This is very interesting. The company has worked on nails, painted nails. You know, if you want Cai Shen Ye, God of Fortune, you sit there and 1 hour, they will paint for you. Or Christmas time, you do your Santa Claus. 1 hour. So this guy said, can I 3D print it? So I said, sure. So he wanted 5 flowers. Okay, I printed 5 flowers. But I don't need 5 flowers. I gave him 5 butterflies. So I printed 10 with butterflies. So this is in the area of art, and it's a SME. So we have been doing quite a lot of small little projects with SMEs. Normally for SMEs, the budget is small. So a lot of supports actually come from Spring. Spring funds 70%. Our latest project, we have just signed on with Rices. You all heard of Rices? You know the orchid, deep in gold? They do a lot of jewelry. They have, because Rices was bought over by BP De Silva, who delves a lot in jewelry. So we have now a project to do jewelry. So soon, I hope to print gold rings for my wife, you know, customize. You know. So not easy, but can be done. People have printed gold. So I'm still waiting for people to give me gold dust. John, give me some gold dust. Printing gold is not about printing. It's about how you manage the gold, because they are very expensive. So every day I have to check my researcher when I leave the lab. You never know. Oh. Very expensive. Every little particle you lose is money. So you need a special design for the printer. We're looking at it. So that's one of the things we want to do, precious metals.
Thank you, Professor Chua. My name is Dr. Ram. I'm basically biomedical scientist. I have been working for 10 years as a cancer researcher. My interest is, I want to ask you 2 questions. One is, the pharmaceutical industries are making difficult for engaging the current research because of the expenditures for the manpower and other resources or machineries. How do you address for their innovation to move on to find the new drugs, whether the 3D machine can print the new drugs formulations in different categories? And another one is the drug screening possibilities for using the three-dimensional tissue, which we can print in different kind of organs or any other resemblance. So it is validating for them for the clinical trial, preclinical trial, rather than to use the two-dimensional cell culture or any other things.
Yes, it's three-dimensional.
Do you have any facility? Because Singapore is moving forward for the biomedical hub of the Asia, not only Asia, to the globe also. If these facilities will be evolving soon, then we can use all these platforms for the local research complexes.
I answer your second question first. We are actually doing three-dimensional. It's not 2D. So it's three-dimensional and it's actually used for drug testing. Now, pharmaceutical, there are some interest, but not a lot of movement so far. I mean, big companies like GSK and all that, I don't know. But as far as my center is concerned, I don't host a lot of pharmaceutical companies. But that is another area that people have worked on. For instance, one area we call is drug delivery devices, DDD. So it's a tablet that is customized, and if you implant that in, actually you don't have to follow your specific schedule to take your medicine, because it will biodegrade, release the medicine at regular controlled pulses. So you're actually taking medicine indirectly in your human body. So every few hours, this thing biodegrade, you get your medicine. Every few hours, get it. So things like that, people are trying to use 3D printer to do it, so they can print tablets and other things. But the area is quite challenging. We have done a bit of work, not easy. Okay. Because if you go for drugs like cancer, because you say you're working in cancer, if you release the wrong dosage, you kill the patient for drugs, for cancer, instead of saving the guy. Right? It's very toxic. Overdosage. Not fair, I always decide. How about this side? Any other questions? Yes? Yes, DHL, ST Logistics, all this related to supply chain, logistics, they are also very concerned because it has changed totally the supply chain model. It used to be designed in one place, print in, or fabricate in another country because it's low cost and things like that. This is all going to be changed. So in short, yes, it's going to change. Yes. Yeah.
Prof. Chua, thank you very much for the talk. I really enjoy it. I just have a question. You mentioned about the machines that cost millions of dollars. Would it come a point where they drop to a price point where it's affordable, like computers and laptops, where you can print in the comfort of your home?
Good question.
Yeah, another question is, you mentioned about not printing weapons of destruction. Then how about, in that case, printing items which are subject to intellectual property protection?
Okay, can. So let's answer the second question again. Ministry of Law came to see me, that's about 4 or 5 years ago. Same thing about IP. They are also concerned. You will recall many years ago when we have photocopying machine, we all have a license because they scared you photocopy money, right? So you even have to track how many machines you have, how many colored piece of paper that you have. So one of the things they worry about is IP issue and how you manage this technology. In any new technology, there will be risks. Just like what once upon a time our ex-George Yeo said, you have internet, you just stand at a window, carry a sword, and then sword at the flies that come in through the window. You cannot stop internet. Internet can tell you 20 ways of how to kill yourself, but it's also very good for finding out other things. So it's good and it's bad. Same thing with 3D printing. You can print guns, you can do funny things, but it's also a good tool. So it depends how you use it. Your first point is about prices of machine. It has tumbled down. Trust me. When we started this work, it was all in at least 6 digits. Today, there are still expensive ones. It's because of patent. Once the patent disappears, prices will come tumbling down. We already see it happening in one area called the FDM, Fused Deposition Modeling. A lot of chip printers that you see out there in the house, few $100s to a few $1,000s, they all belong to this category because this was the first patent to expire. That was like 5 or 6 years ago. And since then, a lot of people jump into the bandwagon and develop printers that sell for a fraction of the price. And in the last few years, 3 or 4 more patents have expired. I see more printers' prices tumbling down. 2 factors are going to be in our favor. First, machine prices come down. Second, more people coming to it. It will, economies of scale, push down the prices of consumables. The materials used for printing is also expensive. But when more people use and more people come in to produce the materials, which there are, the prices will also come down. And it's my belief that soon it will go the same way as computers. In the 1940s, the first mainframe was created. It was bulky, it was massive, it was expensive. So someone was asked to look into a crystal ball to predict how many computers there will be in the future. You know what the guy says? Look into the mirror, crystal ball. He said 6 computers in the world. You and I can start laughing, right? Every one of us has a computer right now in our pocket, our handphone. The direction of printers will go the same. The day will come where all of us will have not a 2D printer, which I think most of you have, but a 3D printer on your desk. It will come. It is just a matter of time. Believe me. If I'm still around, come and say, Prof. Chua, you were right. Many things will come. The day will come with handphone that has different shape. It will come. So again, when it comes, remember, Prof. Chua first told you. But don't need to pay me, just buy me wanton mee. It will come. All this will come. It's just a matter of time. Seriously, trust me.
Sure, thanks very much. I'm interested in 3D or 4D printing of food.
Okay.
Just on top of the talking about pricing, you say the chocolate printer is only 7,000. Is that a lot more inferior than your 2.5 million, 1 million? That's question number 1. Question number 2, I'm personally interested in the personalized nutrition for food, especially for aging population.
Where are you from? Oh, we talk later.
We talk separately. How far are we?
I'm looking for collaborators.
I come from food industry. How far are we in terms of this research? What sort of gaps are we still very much behind?
Now, the reason why the chocolate printer is so much cheaper is based on the technology that's expired. So it's very cheap. FDM machines now are all, you can get in a few $100s. That's why the chocolate printer, 7,000 now, you probably get even cheaper. I bought 7,000 many years ago. Really, it has come down. And mainly because it's not protected by patent anymore. That's the reason why. The $2-3 million is because all those are still protected. These guys spend a lot of money on research. They have to make back some. You have to let them make some money. They spend so much money on research. Your point about food printing, we are actually very new. We are just about 1 year old. It all started from the chief dietitian in Khoo Teck Puat Hospital. The lady bought a printer. Being a non-engineer, don't know what to do with it. So, Prof. Chua, I need your help. So I said, sure. Then we started talking, and then our view is that we should try to develop our printer rather than buy one. Because you buy one, again, it's very expensive. You can develop from one on your own, then you can keep the price down. And our vision is to make it affordable if we can deliver. So we are talking about customizable food. Right now, we're talking about stroke patients and the elderly, but eventually you never know. It might even be for the masses. We'll see how it goes step by step. We are talking to various folks. We are talking to even NTU folks, the lady behind. Recently she came, she belongs to the Food Science and Technology group. Even with NTU, we have so many people, sometimes we don't know what the left and right can do. So we have been talking to them as well. They are the experts. Yeah. One of the problems we learn, right, about food is actually psychological. You dare to eat? That day when I told her that the next year competition we will do food, she agreed with instantly that she will be a judge. Because judge must eat the... Right. I hold you to it. So we have 2 judges from her and another one, I can't remember who is it. Anyway, so we organize the competition every year. I dare not do food because you have to taste to know whether it's good or not, right? And if something happens, how? And then you get entries for all over the world. How do you know what they put inside? Don't know what they print, right? Anyway, that's for another day. Have I answered you? Yeah. Food is really quite exciting. Somehow it generates a lot of interest. And what I understand from Gladys is usually in Singapore, the healthy food is not tasty. The tasty food is not healthy. Think of char kway teow and chicken rice. So can we print it and have both, healthy and tasty? Now let's work together. One last question. Then I will still be here, all right? I'll still be here. If you're interested in the course, you can sign on the spot. If you're interested in the books, we have offers today. I'm not here to make money, don't get me wrong, but in case you want, you can buy. Discount, author's price. Last question. Wow, your last question very effective. It works. All right, if not, thank you very much. Thank you.
So, is there one winner to Professor Chua for
Okay.
his insightful talk?
Thank you. Thank you. Thank you. Thank you. Thank you. My name card is here. If you need my name card, come down and get it. It's free of charge. Then you want to visit me, just drop me an email.